So good day, everyone. We are the group number 2, and we are here to report the Redwood Viscometer for the final project for ME Laboratory. So here are the proponents: Corpus Harris M, Hernandez Jamaica, Nicole Mary Lynette, Ricalde Giancarlo, Santok Gleisel, Zara Mary Donnelly. So for the table of contents, first we have the theories, objectives, number 3 is the procedures, 4 is the simulations, and 5 for the tabulations of values. 6 is for the kinematics viscosity versus temperature, and number 7 is for the computations. So to start up, we have the theory.
The theory. Viscosity is a fluid property that causes a layer of fluid to resist flow over another layer of fluid. The resistance of a fluid to shearing loads is determined by its viscosity. It is a measurement of the internal fluid friction that produces flow resistance. The viscosity of liquids reduces as temperature rises, but the viscosity of gases rises as the temperature rises. Because viscous forces in liquids are caused by cohesive forces and molecular momentum transfer, this is the case. Because of the Because of the closely packed molecules in liquids, cohesive forces are more essential than molecular momentum transmission, and when the temperature rises, the cohesive forces diminish, resulting in a drop in viscosity. In gases, however, molecular momentum transfer takes precedence over cohesive forces. As the temperature rises, the molecule momentum transfer increases and the viscosity of gases rises as well. The following formula is for the case of liquids.
Objectives. For objectives, first, using a Redwood viscometer, determine the kinematic viscosity of a given fluid at various temperatures. Second, to investigate the effect of temperature on the viscosity of various fluids. And lastly, to know how Redwood viscometer determines the viscosity of the fluid.
As for the procedures, we have the following. First, we click on the drop-down list to select the fluid, and next, we click on the drop-down list to select temperature. And after selecting the fluids and temperatures, we click on the left button, so the flow of fluid will then start. As After that, we observe the rise in level of fluid in the container, and then we click on the stop button when the fluid reaches the 50 cc mark. And now we click on the reset button to reset the stop. As for the next one, we then select again the next temperature and repeat all the procedures for all the remaining temperatures. And after that, we perform the same procedures for all the readings, select the next fluid from the drop-down menu. So we repeat the procedures for the selected fluid in various temperatures, and after that we observe the variation in kinematic viscosity with change in temperature. Then we click on the plot button to plot the comparative graph for both fluids. And lastly, we compare the graph between kinematic viscosity and temperature, and we can see on the figure next.
So for the simulation, we will show you a video about our virtual simulation of redwood viscosity using engine oil and glycerol as liquids. So for the tabulations of values, these are the values from the simulation. These are the values from the simulation of engine oil and the glycerol. Kinematic viscosity versus temperature. This is the graph plotted from the virtual simulation conducted.
So for the computations, to determine the kinematic viscosity, V is equal to AT minus B over T, wherein V is equal to kinematic viscosity in centistokes, A is equal to viscometer constant, which can be determined by equipment, T is equal to time of flow in seconds, and B is equal to coefficient of kinetic energy. For simulation number 1, at 55 degrees and 525 seconds, V is equal to 1.30 centistokes, wherein where A and B is equal to 2.47 and 0.50 respectively. At simulation number 2, at 60 degrees and 325 seconds, the viscosity is equal to 0.80 centistokes. For simulation number 3, at 65 degrees and 250 seconds, the viscosity is equal to 0.62 centistokes. For simulation number 4, at 70 degrees and 135 seconds, viscosity is equal to 0.33 centistokes. For simulation number 5, at 75 degrees and 83 seconds, viscosity is equal to 0.20 centistokes.
So these are the computed values for the glycerol, and we will no longer elaborate it. For the first simulation, the calculated value was approximately 1.15 centistroke. For the second simulation, the value calculated was approximately 0.81 centistroke. For the third simulation, the computed value was approximately 0.58 centistrokes. For the fourth simulation, the calculated value was 0.29 centistroke, and for the last simulation, the calculated value was 0.19 centistroke. So for the so now for the observation. As the simulation goes by, we further observe that the viscosity level decreases as the time of flow decreases, which indicates that they are proportional to each other. Since the viscometer is constant, is determined by the equipment, the temperature barely changes its value, that the values are close to each other, and cannot be said that the viscosity, when an engine is used, is not dependent on the temperature of the liquid used in performing the experiment. Under increasing high pressures, the viscosity of the liquid also decreases. So that's all for our virtual lab, and thank you.